Have you ever wondered how psychedelic substances like LSD, psilocybin, magic mushrooms, or DMT create such profound and mind-altering experiences? We often hear about the subjective effects, the altered perceptions, the intense emotions, the sense of unity, or ego dissolution. But what's actually happening inside the brain? One increasingly compelling theory centers around a concept called entropy. In simple terms, entropy is a measure of disorder, randomness, or uncertainty within a system. Think of a perfectly organized deck of cards, all in order by suit and number. That's low entropy. Now shuffle that deck thoroughly. That's high entropy. In the context of the brain, entropy refers to the complexity and flexibility of neural activity. A brain in a highly ordered, low-entropy state tends to have very predictable and constrained patterns of communication. Think of it like a highly structured, routine-driven thought process. Conversely, a high-entropy brain state is characterized by a much wider range of possible neural connections and activity patterns. It's more flexible, more adaptable, and capable of exploring a broader landscape of thoughts, feelings, and perceptions. Now, here's where the psychedelics come in. Research, particularly using brain imaging techniques like fMRI and EEG, suggests that psychedelic substances dramatically increase brain entropy. They essentially loosen the constraints on neural activity. This increased entropy manifests as a surge in connectivity across different brain regions. Areas of the brain that don't normally communicate much suddenly start talking to each other. This is sometimes referred to as increased global connectivity. The default mode network, a brain network associated with self-referential thought and mind-wandering, often shows decreased activity, contributing to the experience of ego dissolution. While at the same time, other networks become hyper-connected. Think of it like this. Your brain normally operates within certain established pathways, like well-worn roads. Psychedelics temporarily dissolve those roads, allowing you to explore uncharted territory. This increased communication and flexibility can lead to novel insights, shifts in perspective, and the breakdown of rigid thought patterns. This isn't just random noise, though. While entropy is about increased disorder, it's not complete chaos. The brain still maintains a degree of structure, but that structure is far more flexible and dynamic. It's this balance between order and disorder that may be key to the therapeutic potential of psychedelics. For example, in conditions like depression and anxiety, the brain can become stuck in negative, rigid thought patterns, the kind of low-entropy rut. Psychedelics, by increasing entropy, might help break those patterns, allowing the brain to explore new, more adaptive ways of thinking and feeling. This is supported by growing evidence showing the effectiveness of psychedelics in treating these conditions. It's important to note that this entropy increase is temporary. The brain eventually returns to its baseline state of entropy after the psychedelic experience. However, the insights and shifts in perspective gained during that high-entropy state can have lasting effects, potentially leading to long-term changes in thought patterns and behavior. The entropy increase theory is still a developing area of research, and it's not the whole story of how psychedelics work. There are many other neurochemical and psychological factors at play. But it provides a fascinating and powerful framework for understanding the profound effects of these substances on the human mind. It suggests that, at least in part, psychedelics work by temporarily increasing the brain's capacity for exploration, flexibility, and ultimately, transformation.